Camera! Pressure!
Yeah, it worked. It's just that I have to change my thing a little bit. Okay. Never mind. Okay, that's over there. Thank you. Okay. Sorry. Okay, we have 5 minutes. Great. This is lovely. All right. So exponent rule is the finale. I was going to wait on this, and I thought, you know what? Let's just get the exponents done. Is that okay? You up for that?
Yeah, let's
Because you've done all the hard stuff, right? And you've learned the rules. So make sure you have your notes out. You got to take notes on this. Okay. The one thing, guys, the one thing that we haven't covered, well, we did once, but not as an official lecture, is talking about parentheses with exponents, okay? Parentheses are really important to be careful of. But like if you had something like this, x cubed to the 4th power. We got to remember what our exponents. Notice we have an exponent of an exponent of an exponent. Do you see that?
Yeah.
Exponent of an exponent. What does of mean in math? Multiply. Exponent of an exponent. So I'm going to first do it the long way, and then I'm going to show you the shortcut. The long way, an exponent says, this 4 says everything next to it is being multiplied times itself 4 times, right? So this means x cubed times x cubed times x cubed times x cubed. You guys all agree with me on that? Right? Pretty straightforward. So what does that equal? X to the 3 plus 3 plus 3 plus 3,
12.
which is 12. Now, can you see any shortcut you could have done from here?
Multiply the.
Very good. Bella, well done, my dear. That was awesome. Yeah, thank you, Skylar. Yes. When you have an exponent of an exponent parenthesis exponent, you multiply them. That's the shortcut. So it becomes really, really fast and really easy. All right, so what's this? X to the 8th times, up to the raised to the 7th power.
X to the 56.
Right, so easy, right? So easy. So what about this? What if we have two things? What if we have x, y squared raised to the 9th power?
Wait, what is it? X, Y squared? That'll be X, Y to the 18.
Okay.
No, it'd be X to the 9th times X and then Y to the 18.
Notice when I don't write an exponent, it means there is one, right? What is that one? It's a 1, right? So it's going to be x to the 1, 9 times 1, which is 9. And then y to the 18th, right? 9 times 2. Yes? Everybody get that? Okay, let's try another one. X to the 4th, y to the 6th, raised to the 10th power. What?
X to the 40th and Y to the 60th.
X to the 10 times 4 is 40. Y to the 10 times 6 is 60. This is a piece of cake, right?
Yeah.
Like a total piece of cake.
What if you
Now,
get really big ones?
Now, the one where things get a little more confusing is when it's like this: 2x squared raised to the 3rd power.
2 to the 3rd power is x to the 6th power.
6.
Right? Yes. So then it'd be 2 to the 3rd power.
No, it'd be 2x to the 6th
So it'd
power,
be
right?
8x to the 8x to the 6th power.
Your mom.
6.
It's 8x to the 6th power.
I'm getting a lot of answers here, right?
It's 8x to the 6th power. It's 8x to the 6th power.
So I'm getting
How's it
6.
8x?
I'm getting 6x to the 6th power. I'm getting 8x to the 6th power. I'm getting 2x to the 6th power. Which one is it?
8x to the 6th power.
So guys, listen. Guys, listen. Just like this one. Look at this. Everybody, come. Skylar, it can't be noisy. Come on. All right. I have two things in the parentheses here, right? My exponent on the outside affects everything inside, right? So I didn't have that little 1 there by the x. I just had the x. But that x does have a 1 exponent, so it's 9 times that hidden 1 exponent, right? The same thing is true with the 2. The 2 is a number just like the x was a number, right? But I didn't write an exponent, because usually you don't when you're writing a number, right? So you got to think about it as, oh, well, that is 2 to the first power. Therefore, it's going to be 2 to the 3 times 1, or 2 to the third power, x to the 3 times 2, 6, which is equal to 2 times 2 times 2 is 8, x to the 6. Now, when you're dealing with 2's, and it's not too big of an exponent, I prefer you writing it like this than like this. But if I had given you something like this, 8x to the third to the 9th power, then definitely do 8 to the 9th, right? You don't do, let's see, 8 times 8 is 64, times 8 is, you don't do that, right? You don't do that. You just do 8 to the 9. I mean, as you move forward, and like some of you have fancier calculators, and those fancier calculators allow you to actually solve 8 to the 9th really fast. But without those, it's not very fast.
So, like, on the homework, would you prefer us doing, like, the entire step? Or, like, if we already know the answer and we did, like, the math inside our head, could we just put, like, 8x to the 6th?
Yeah, that's fine. Totally fine. I'm just showing you what, what's actually happening. Wait, hang on 1 second. Let me just look and see. So what if I gave you this? What if I gave you something like this? 3x to the x to the 4th to the 3rd, y squared to the 5th. What would you do with that?
It'd be 3x to the 12 y.
So it's really just 3, right? We got a 3 there. And then we have, this is an x and this is a y, right? They're not the same variables, right? So it's going to be x to the 3 times 4, which is 12, right? And then y to the 5 times 2, which is 10. You're done. It's easy. Piece of cake. What if, last one. What if I give you this? X squared over y to the 5th. Oh, wait, raised to the 4th power. Sorry.
X to the 8th over y to the...
Yeah, you're going to still multiply this times this exponent, this times this exponent. So it'll be x to the 8th over y to the 20th. Okay? All right, I got to go.
You're like, why? No.
That's it. That was the fastest lecture ever.